tetrahedral field splitting. It is a previous year question. The d electronic configuration of COCl4 2- in tetrahedral field is EMT2N. Find M and the number of unpaired electrons in the complex. The complex given to us is CO Cl4 2-. Cobalt is the central metal atom. Then Cl4, chloride ions are the ligands. There are 4 ligands, so it is a tetrahedral complex. First, we have to find the oxidation number of cobalt in this complex. Let us take it as X for cobalt, plus chloride ions are having -1 oxidation number. So -1 into 4. 4 ligands, 4 chloride ions are there, equals overall charge is -2. So X minus 4, -1 into 4 is -4 equals -2. X equals, this -4 when it goes to the other side will become +4, and this -2 is already here. 4 minus 2, which is equal to 2. So X equals +2. So in this compound COCl4 2-, cobalt is in its +2 oxidation state. We know the atomic number of cobalt as is 27. If we write it in the short form, we can write it as argon. Argon is having 18 electrons. 18 plus 9 is 27. We have to accommodate 9 more electrons. So that is 3d7 4s2. This is the electronic configuration of cobalt. But what we have here is CO2+. 2+. That means 2 of these outermost shell electrons will have to be removed. So the 4s2 electrons should go. Then that will give us Ar3d7. So we are bothered only about the d orbitals in this particular case. So let us draw the diagram of the d orbitals. Five d orbitals. These d orbitals under the influence of the ligand. The ligand, as you know, are chloride ions. The chloride ions, that is in the tetrahedral field. So how many electrons are there? 7 electrons. Let us place those electrons in the orbitals. 1, 2, 3, 4, 5. 7 electrons are there. So first one will be paired, second one will be paired. Now these orbitals will split into, remember this is the tetrahedral field. So they will split into the E set and the T2 set. T2 set having higher energy and the E set having the lower energy. Whatever the splitting energy or this energy gap between the two sets is small, since this is a tetrahedral splitting. It is a weak field ligand also coming. So we can arrange the electrons like one here, one here. Since this energy gap is small, these electrons, the rest of the electrons can go to the top also. So they will go like this, 1, 2, 3. Now 5 electrons have been filled. Each orbital is singly occupied. Now the remaining 2 electrons, one will come here and the other will come here. So the E orbital is, E set is having 4 electrons. That is, T2 is having 3 electrons, E is having 4 electrons. I will just draw it once more like this. E is occupied like this. If we write the d-electronic configuration after the splitting, we can write it as E. How many electrons in E? 1, 2, 3, 4. E4, T2, 1, 2, 3. 3 electrons. Now we have been told that the d-electronic configuration in the tetrahedral field splitting is EM T2N. What we have to find is this M. We are asked to find M here. So here we have 4. That is M is equal to 4. That is the number of electrons in the E set. And the next part of the question is number of unpaired electrons in the complex. How many unpaired electrons are there? These electrons in the E set are paired, whereas these are singly occupied. 1, 2, 3. So number of unpaired electrons equals 3 unpaired electrons.